This video is on section 2.4, which is set operations and Venn diagrams with 3 sets. So we're going to do what we did in section 2.3, but we'll be using 3 sets. Same process, just 3 sets to deal with, which means it just makes the problems a little bit longer for us. Got to remember, you got to follow order of operations. So this says B intersects C in parentheses. We've got to do this in parentheses first. So this will be set A, union, with whatever happens for B intersects C. Intersect means what's in common. So what's in common between B and C is 2, 3, and 6. So this is the set that contains 2, 3, 6. Set A contains 1, 2, 3, 4, 5. That's set A. So what we're doing is set A, union now with this new set 2, 3, 6. Remember, union means to just unite, put these all together into one set. So that's 1, 2, 3, 4, 5. That's from this set. Look over here, we already have the 2 and the 3, throw in the 6, and that is our solution right there. This next one requires us to look at 2 different parentheses. This looks at A union B. Erase those marks. This is A union B. Union means to take these 2 sets and unite them. So that will give us 1, 2, 3, 4, 5, 6, 8. Intersect with union A and C. So if we do the union between A and C, we will get the set that contains 1, 2, 3, 4, 5, 6, 7. This symbol says intersect, so we are looking for what's in common. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and that's all we have in common. The next one I'll do up here says A intersect B union with the complement of C or not C. Do what's inside the parentheses first, which is B union not C, but I better get the not C to begin with. So not C, remember, is to look at set C and eliminate everything out of the universal set that's in C, which is 2, 3, 4, 6, 7. So not C contains 1, 5, 8, 9. And I want to union that with set B. So this set and this set unioned. So that will give me 1, 2, 3, 5, 6, 8, 9. So that's my set for this right here, B union not C. I have to intersect that with set A. Set A is 1, 2, 3, 4, 5. Intersect that, 1, 2, 3, 1, 2, 3, 5. Those are the only things that are in common. So this is 1, 2, 3, 5. So the way we do this with 3 is similar to 2. It just takes more work because there are 3 sets. Remember to follow your order of operations. Before we do Venn diagram problems with 3 sets, let's look at a blank 3-set Venn diagram and name all of the regions. We want to start in the innermost, most specific region, which is this in here. This right in here, this portion here, is in set A. It's also in set B. It's also in set C. Therefore, the labeling on that little region right there is set A intersects set B intersects set C. So I just made up some names here. Let's say set A is blonde, B is the blue-eyed people, and C are the tall people in the class. So A intersect B intersect C would be the list of all the people who are blonde, blue-eyed, tall. Now, go up here to set A and B. We've already looked at 2 sets intersecting, and we know what we've always called this in here was A intersect B. Like all of this would be A intersect B. But I only want to look at A intersect B. This right here, just this portion right here, is the people who are blonde, blue eyes, not the tall people. They're in this region. So in the 2 set, we called this whole thing A intersect B. And yes, this is A intersect B. It's still part of the A intersect B set. It just happens to be more specifically the A intersect B intersect C people. So same idea here. Let's do these 2 sets, set A and C. This right here, you would want to call A intersect C, but it's just this region we label as A intersect C. So these are the blonde, tall people. And this over here, B intersects C. These are your tall, blue-eyed people. And then A, B, and C, these are just the people who are part of set A, which is just the blondes. Just the blondes. They're not blue-eyed, they're not tall. This is set B, this is just the blue eyes. They're not blonde, they're not tall. And this is just the set of people who are just tall, but they're not blonde and they don't have blue eyes. This is the universal set. This would be any of the people who are neither blonde, blue-eyed, nor tall. They might be brunette, brown-eyed, and short. Sometimes they ask us to do the same thing using a Venn diagram. So let's list these things. And remember from before, the Roman numerals are just naming the regions. The actual elements are the numbers 3, 6, 5, 7, etc. So Part A asks us to just name what's in set A. What's in set A is everything in here, which is 11, 3, 12, 5, 7, 6. And remember, you can put that in any order you want. I just looked at it kind of counterclockwise. Then we want B, which is asking us to do A union B. A union B is everything that's in A, B. So starting over here is 11, 3, 12, 5, 7, 6. Notice that's what I had in A already. And then I want to unite that with the stuff in B. I've already named these things, so right here will be 1, 2, 10, 9. Part C asks us for B intersect C. Remember, intersect is what's in common between B and C. That would be in this region right in here. That's our B intersect C region. So what's there is 5, 7, 9. D asks us for not C, or the complement of C. To me, the best way to do that is to color in the C. Now, everything there is going to be eliminated, and we will list what's not colored in. So that is 11, 3, 12, 1, 2, 10, and don't forget the 4 over here in the universal set. So that is our set of not C. Last thing is A intersect B intersect C, and you should remember from one of the lessons previous that A intersect B intersect C is just this portion that's in here, and that is 5, 7. Same kind of problem here. Let's use the Venn diagram to do those same things. Set C, this is A, set C is everything here, which is 5, 6, 7, 8, 9. And remember, these are all sets, so be sure you're using your braces when you enter those. Part B asks us to do B union C. Set B and C. Here's B, all of this stuff in here. Here's C, all of this stuff in here. So just list these. This is 12, 5, 7, 1, 2, 10, 9, 6, 8. Part C asks for A intersect C. A intersects C is where set A and set C have something in common. Set A is here, set C is here, so A intersects C is this little wedge right in here, which is 5, 6, 7. D asks us for not B. So like I did on the previous one, I will color in everything that's in B, and what I will list is everything not scratched out, which is 11, 3, 6, 8. And 4. And E asks for A union B, union C. Now union means we're going to unite all of A, B, C. So it's everything listed except this 4 right here. So that will be 11, 3, 12, 5, 6, 7, 1, 2, 10, 9, 8. In whatever order you want to put them in. This example will show us how to construct a Venn diagram from the elements. We've got the elements A, B, C, and set U, our universal set. To do this, we want to put the elements in the innermost region and work outward. Remember what this in here was? This was our A, intersect B, intersect C. So we need to look at these 3 sets and find what the intersection is of those 3 sets. So what is in common to all 3 of these? We don't have an A in all 3. We do have an E in all 3. We have an H in all 3. Those are the only elements that we have in all 3 sets. So A intersect B intersect C will just be the elements E, H. I will put those right in here. This is E, H. The next thing I need to do is look at the double intersections, as in A intersect B, A intersect C, and B intersect C, because that will help me fill in what goes in those 3 places. So I look at your sets, look at A and B. What's in common to both A and B will be E, G, H, and that's all. So A intersect B has E, G, and H. And how I place this now, this remember was E, H. E and H have already been placed. So G has to go in this region up here for A intersect B. So the only thing right here is G. I will repeat that for these other sets. A intersects C, what's in common to those 2 are A, E, and H. A, E, and H. A intersects C is right in here. What's already here is E and H. What I need to place in the A intersects C is A. Same process with set B and C. What's in common to those will be E and H. Now E and H are already placed right here as part of A intersect B intersect C, which just means there's nothing new that goes in that little blank spot right there. Now I can look at the individual sets A, B, and C and determine what's going to go in these bigger regions. Set A is supposed to have A, D, E, G, H, I, J. Well, I've already placed A, G, E, and H. So what's left for right up here is D, I, and J. Same thing for set B. For set B, I'm supposed to have B, E, G, H, L. I already have E, G, and H. E, G, and H are already there, so this will be B, L. And set C, supposed to have A, C, E, H. I already have A, I have E, I have H, so we're going to have a little C go there. And don't forget to place elements that are in the universal set that have not already been placed. The only 2 elements that have not already been placed are F and K. So that's what needs to go down here, F and K.